Okay, I'm waiting for my iPad to connect. So we're going to do 10.1 sequences, series, and sigma notation. I'm going to use the calculator again, so we're going to have a couple things we're going to have to look at using the calculator. If you have the NSpire, you might want to check that out. But basically, when you have sequences, it's you're going to have either an infinite or a finite. And what the difference between the two of those are, well, first of all, let me tell you what a sequence is. So a sequence is an ordered list of numbers and finite has a finite number of terms. Okay, so you have a finite, it ends. So you might think, let's see, maybe 1, 2, 3, 4, and it ends right there. There's no more, it's done. So you have a finite number of terms. Okay, and then infinite means you're going on, you're going to continue without end. So you have a sequence that's an ordered list of numbers that is going to continue without any end. And that might look like this: 1, 2, 3, 4, and then you'd put dot, dot, dot. Okay? We have explicit versus recursive. An explicit formula allows you to find any term, no matter what it is. If it's the 100th term, the 5 millionth term, you don't have to know the previous ones. But the recursive is where you have to know the previous terms before the term you need. So if you needed the 99th term, then you'll need to know the 98th term. So explicit kind of writing like a third grader right here, so I'm going to erase that. Formula allows you to find any term you want. Recursive allows you to find a term only if you have the previous, if previous is given. I keep hitting my computer, and that's why that thing keeps popping up. Okay, so our first thing is we're going to find the first 4 terms, or the next 4 terms of this sequence. And so you kind of have to look at the numbers and kind of investigate what you think, whether it's going to be an addition happening, multiplication, division. And the first thing is probably look for addition and subtraction would probably be the biggest to go with first. Think about, what do you need to go from 2 to 7, and from 7 to 12, and from 12 to 17. And I see right away that I would, if I added 5 to these, so 17 plus 5 would give me 22. 22 plus 5 would give me 27. And 27 plus 5 would give me 32. And 32 plus 7, or plus 5, would give me 37. So I'm just adding 5 to each of those terms. Now, here it asks us to find the first 4 terms of this sequence given this equation. So now we can come in and write and figure this out. So, oops, I went too far. So the first thing you got to do is we have to talk about notation. Okay, so this n right here, that's the nth term. If we want to know the first term, we're going to write a sub 1. And everywhere in this equation that we see n, we're going to replace that with 1. So order of operations holds true. You got to do the exponent first, which -1 to the first power is -1. Then you're just going to be multiplying these, and this is going to give us -2. So that's the first term. The second term is going to be 2 times 2 times -1 to the second power. So you see where everywhere I saw that n, I replaced it with 2. That's the second term. So -1 squared is going to give us 1 times 2 is going to give us 4. I'm going to continue this process on. You'll now notice that I'm going to go to I'm at an odd exponent, and anytime I take it to an odd exponent, a negative number, it's going to be negative. So I've got -1 times basically 6, which give me -6. So I'm alternating between positive and negative. And then my last one, a sub 4, it's the fourth term, 2 times 4 times -1 to the fourth term, or fourth power. So that's going to give me now a positive value, so this is 8. So my first 4 terms are -2, 4, -6, and 8. Example 3, find the fifth term of the recursive term defined. And it's recursively defined, and what that means is I have to know the previous term to be able to figure out what the next term is. So I can't jump to the fifth term right away. I have to figure out what the second term, the third term, and the fourth term, because the fourth term is what is important to figuring out what the fifth term is. And this is what right here signifies that you're looking at the previous term. Because remember I talked about n, the nth term. Well, if you look right here, this is n minus 1. So it's the one right before it. You have to start at n greater than 2 because you already have the first term. So you're looking one with that. So this just tells you that you have to start with, you already have the first term, so you got to go to the second. So you already have a1, a2, I almost wrote a 2 there. A sub 2 is going to be the first term plus, anytime you see n, you're replacing it with this number here, minus 1. So 3, I forgot to multiply it by 2. I'm like, wait, I got something different on my notes. Okay, so this is 2 times 2. That's what I got confused with the 2. So this would be 4 minus 1, which would give me, or 5. 5 minus 1, which would give me 4. Because 1 plus 4 would give me 5, minus 1 would give me 4. Then I'm going to do a sub 3. Well, that's the term previous, which is 4 plus 2 times, got it right this time, minus 1. So we've got 4 plus 6 would give me 10, minus 1 would give me 9. A sub 4 would give me my previous term, which is the a sub 3, plus 2 times 4 minus 1. 8 plus 9 would give me 17, minus 1 would give me 16. And now I finally get to answer the question that they wanted. A sub 5 would be the previous term plus 2 times 5 minus 1. And that's going to give me 10 plus 16, which would give me 26, minus 1 would give me 25. So I had to do all that work because it's recursive. If I had the explicit formula, then I'd be able to go straight to it, but I don't have that. I'm given the recursive formula, which means I have to go all the way through to find that fifth term. Okay, convergent versus divergent. So if a sequence has a lot of terms approaching a certain number, then it converges. If not, it diverges. So if you converge, that means when you plug the numbers into the equation, like the first term, the second term, the third term, you are going to approach a number, such as maybe 0. So convergent, if a sequence has a limit, meaning you're approaching something. This is limit. No, okay. The terms, approach a value. If it doesn't approach a value, it's called divergent. So it does not approach. There is a bummer. If you're not given a graph where you see all the different numbers that it's putting in, you're going to actually have to figure it out. It doesn't approach a number. So you actually have to plug numbers into your sequence to determine, which we're going to do for the next couple ones. So we're going to determine if this converges or diverges. That means we need to be approaching a number. We need to be getting really, really small or really, really big to a number, like going to that number. It's a limit. So I guess maybe not going really, really big. I would see more going really closer to 0. Okay, so here's what we're going to do. We're going to put a couple of them in. Start with a sub 1. So negative 3 times 1 plus 12. And that would give me 9. A sub 2, that's going to be negative 3 times 2 plus 12. Negative 6 plus 12 would give me 6. A sub 3, negative 3 times 3 plus 12. Negative 9 plus 12 would give me 3. Let's try another one to see, because currently I don't know if I'm approaching anybody. It doesn't look like I'm not going to anything. Negative 3, 4 plus 12 equals 0. We're not approaching any number, so this is probably going to be divergent. This is divergent. Now let me show you one where you'll see that it's going to a specific number. Like if you were to graph this, you look, it's just kind of going, these numbers are just kind of going down. They're just going down by a specific 3. So you're up here at 12, boom, boom, boom. They're just going down. They're not approaching. The limit is going to no specific value. But the next one, when we look at, you'll see kind of, hopefully a little bit better, that it's approaching something. Okay, so here we're going to figure out whether it's convergent or divergent. I kind of gave you a hint that it's going to converge. So let's put in some values. We already have the 1, so we can go to a sub 2 because we need the previous term, and we do have the previous term. So a sub 2 would be negative 1/2 times 36, which would give me negative 18. A sub 3 would be negative 1/2 times negative 18 would give me negative 9. Positive 9. 7th grade math is not going to take me down. A to the 4th 1/2 times 9 would give you negative 4.5. Okay, so if you were to graph these and you were to look at this, we are kind of going, it looks like we're going in the negative, and then we shoot up here to the positive. And then we come back down to the negative, and then guess what? We're going to come back to the positive. And each time we go down, or each time we increase these numbers of terms, we're just going to kind of like isolate or oscillate close to 0. So this right here is approaching 0. So if you think, here's negative 18, then we come up here, this would be positive 9. Then we come down here and we're closer, which I didn't draw it very closer, but we're getting closer to the y equals x, or y equals 0 line. And then, sure enough, cut this in half. We're going to be in the positives up here, but we're going to be even closer to that 0 line. Whereas the other graph did something where it was just going down like that. So you have to really kind of look at your data to see whether you converge or diverge. So that graph actually did converge. You converged to 0. Okay, looks kind of weird, but that is a time symbol, that box right there. And we're going to see if it does converge or diverge. A sub 1. Okay, so we've got negative 1 to the first power times 1 over 4 plus 1. And that would give me negative 1 over 5. So that's negative 0.2. A sub 2 would be negative 1 squared times, that's a times, very bad times 1 over 2 times 4. Sorry, I didn't do the 1 there. Plus 1. So that's 1 times 1 over 9. So that'd be 2. Oh, is this time? I forgot to do that. This is n, so this would be 2. I'm losing it. So this would be 1 times 2, which would give you 2 over 9, which is 0.22. And then we've got a sub 3, which is negative 1 to the third power times 3 over 4 times 3 plus 1. So that would give me negative 3 over 18, which when I put my calculator to do that is going to give you negative 2.3. If you were to kind of look at this graph, it does give the impression kind of like the other one, but you're over here, the first term, let's say, is at negative 0.2. Just plotting a point. And then we come up here to 0.2. And then we come down here, we're getting even further away from 0. This value is further away than, like if you think of this as 20 cents, this is 23 cents. You're going further down, not converging closer to a point. You're getting farther away on this side and probably going to get farther away on that side. So this is divergent. It's hard to see unless you're going closer. We were getting on that other graph, we were getting closer and closer to 0. Yes, we were fluctuating between negatives and positives, but we were cutting that value in half. So this diverge. It's not going to approach any specific value. Okay, so we got series. So series are the sum of all the terms in a sequence. It's where you're adding up all your sums, all your terms. So it's the sum of all the terms in a sequence. You have finite versus infinite. Finite is where you have the sum of a set number. It doesn't continue on forever. Whereas an infinite is going to continue on. You have no end to your series. So you're a sum of a set number. It's finite. It ends. So 1 plus 2, I meant to do the one that was plus 3 plus 4. It's ending right there. Whereas the sum of this one has no end. Sum of a set, and actually I should probably say sequence, of numbers without end. Okay, so we usually talk in terms of equations when we're dealing with sums. If we've got the nth partial sum, then that means that we are finding the sum of the nth terms of a sequence. Okay, so here's our first one that we're going to work with. So if you had to find the fourth partial sum, that means you're going to add a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, and that would equal the sum of the fourth terms. So if we put 1 in, a sub 1, we would get negative 2 to the first power plus 3. So that would give me 1. So a sub 1 is 1. A sub 2 would be negative 2 to the second power plus 3. So that'd be 4 plus 3 would give me 7. A sub 3 would give me negative 8 plus 3 would give me negative 5. Now I'm doing these in my head, sorry. I guess you do this. And then a sub 4 would be negative 2 to the fourth power, which would be 16 plus 3 would give you 19. And when you add those all together, you get 22. Okay, so then we have S3. So this is looking for you're summing the first 3 terms of this equation. And all you're going to do is you're going to figure out what a sub 1 is, a sub 2 is, and a sub 3 is. I believe this is a 4, so this would be a sub 1 would be 4 over 10 to the first power. A sub 2 would be 4 over 100. A sub 3 would be 4 over 1,000. Thank gosh we don't have to go any further. So when we add these on our calculator, we get 111 over 250, or that would be 0.4 repeated. And I did that specifically on my calculator. Do not think I did that in my head. Okay, sigma notation. This looks scarier than it is, but we plug it in our calculator, or you plug the values in and just add them. This is just summation. So this is giving you directions. It says for any sequence, a sub 1, a sub 2, a sub 3, a sub 4, and so on. The first k terms is denoted by k, where n is the index of the summation, that's where you start, and k is your upper bound, and 1 would be your lower. So basically what you're saying right here is you're saying, okay, start with the first term and go all the way to k. Add the first term plus the second term, third term, fourth term, all the way up to wherever k is. And that's what we have right here. So this is sigma is the notation for sum, and this is what term you're going to add to. Term adding to, and this is where you start. This is the term you start with. Okay, so for us, if you get to use your calculator, I'll show that, but if not, you're just going to basically come in and just say, okay, a sub 1 would be 4 times 1 minus 3. 4 minus 3 would give you 1. A sub 2 would be 4 times 2 minus 3. 8 minus 3 would give us 5. A sub 3 would be 4 times 3 minus 3, and that would give us 9. A sub 4 is going to give us 4 times 4 minus 3, which is 13. A sub 5, which I'm stopping at 5, and the reason I'm stopping at 5 is this is my last one. 4 times 5, really liking the 3, minus 3, so 20 minus 3 would give me 17. You're not done. You actually have to add them. 1 plus 5 plus 9 plus 13 plus 17 would give us 45. If you got to put it in your calculator, which I will show you, if you got to put in your calculator, you would go math, and you will scroll all the way down to summation, which is right there, and you hit enter, and you just basically fill in. Now, calculator can't use n, so you have to use x, so you replace everywhere you see x with, or n with an x. And I'm going to do 4x minus 3 and hit enter, and it gave me 45. So it's doing that all without me having to figure it out. If we figured out the next one, which on your notes I believe is summation of from the first term through the seventh term. Actually, that's the third term. I need bifocals. So go, oops, I hit alpha. Second, quit. Math, Scroll down, went too far, hit enter, X, and then 3, I hope, if I can't see it, I'm sorry guys, 7, then alpha y equals, enter, 6x minus 3, oops, I'm in exponent mode, delete, 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 scroll down, oops, I still have that thing there, minus 3 over 2, go down to 2, and hit enter. And I get 135 over 2. So that's example, I wonder if it'll let me do that. That's this one that I just found. So I just use that in my calculator. If we didn't have our calculator for the next one, the very last one, you would just do, so this one, it means just to keep going, what it's approaching. So you have 7, the first term would be 7 over 10, plus the second term would be 7 over 100, plus 7 over 1,000, and this would keep going. And if you notice, this would be 0.7, this would be 0.07, and this would be 0.007. So this is approaching approximately 0.7. Even though all these things are going past it, if you were to add them, you're still approaching that value of it. So it's just close to it, probably repeated decimal. And then how you wrote repeated decimals, I don't know if you remember, it was 7 over 9. Those were repeating decimals when you wrote your fractions in 7th grade. So I think we are actually done. Let me see. Oh, so I already actually showed the calculator terminology. So we are done.